Here are vectors. So I'm going to go through everything you're going to need to know about these. Some of them you'll find more difficult than others, but it is practice. And I will give you these notes at the end as well. Okay?
Yeah.
Okay, so the first thing to know about vectors is the difference between a scalar quantity and a vector quantity. A scalar is one that has just size, and they can be just numbers, so 3, 5, 12, 43, all of those are scalars. A vector is one which has both size and direction. So you've got an example there. You could have 6 west or 3 minus 4. Now, have you seen that notation before in a bracket like that?
Yeah.
Yeah, do you know what we call that?
I remember in translation.
Yes, it's in translation. This is called a... Okay, it's called a column vector. Okay, I'll come back how to read them in a little while, but you should know that's called a column vector. Oh, there we go, straight away. That 3, negative 4 is known as a column vector. The top number represents the movement in the horizontal direction. So if it's positive, you're going to be going right. And if it's negative, you'll be going left. And the bottom number represents movement in the vertical direction. So positive is up and negative is down. So to calculate the size of a column vector, you need to use Pythagoras. So I'm going to just extend the page a little bit. Yeah, that's a bit too far. Do you remember the column vector that we had was 3, negative 4? Yeah?
Yeah.
So 3, negative 4 means 3 to the right and 4 down. Okay? Now what if I wanted to go straight from my starting position to my ending position? I'd follow the red arrow there, yeah? That red arrow is known as a resultant vector. And we can find that using Pythagoras because this is a right-angled triangle. So if I use a squared plus b squared equals c squared, I will get 3 squared plus negative 4 squared equals c squared, which is 9 plus 16, which is 25, and then the square root of 25 is 5. So the resultant vector of that column vector would be 5. Okay.
Okay.
Column vectors can be added. So if I take that 3 minus 4 and I add minus 5, 7 to it, what I do is I add the bits at the top together and I add the bits at the bottom together. So 3 plus negative 5 would give me negative 2. And minus 4 plus 7, if I add them together, I could get 3. Is that okay?
Yeah.
And multiplied, or both. So if I wanted to double that 3 minus 4, a 2 could be in front of it. So if I doubled 3, that would make 6. And if I doubled negative 4, that would make negative 8. And then if I added the minus 5 and 7 to it, like I did in the previous line, I would get 6 plus minus 5 and minus 8 plus 7, giving me 1 and minus 1. Is that alright?
Yeah.
So the magnitude of the resultant vector can be calculated using the method on the previous slide, Pythagoras. What would the magnitude of 1 minus 1 be? Okay. Think about it. What does 1 minus 1 mean? What does the top number represent? The top number was horizontal movement. So it would be
Okay.
1 to the...
Right.
Good. And the bottom number would be 1...
To the left.
No,
I mean, down.
down. Okay. So if I was to
Yeah.
draw that out, yeah? Here's my arrow. Here's another one. Yeah?
Yeah.
We're going 1 right and 1 down. How am I going to find out what my resultant is, which I'm going to call R? Well, we need our Pythagoras. No, why am I getting that all the time? No, that's very odd. Okay, I'm going to have to shrink down the 2's then. For some reason it's not wanting to copy it. Never mind. Unless no, it doesn't like that for some reason. Okay, we'll just do it the long way. A squared plus B squared equals C squared. Okay, let's move this. So we're going to have 1 plus 1 equals R. No, it doesn't want it. One squared plus 1 squared equals R squared. What's 1 squared?
1.
Good. And what's 1 squared?
1.
Good. Equals R. And 1 plus 1 is 2. So R will equal, I'll put it up here and I'll draw in the square root. Okay, R is going to be equal to the square root of 2. Is that alright?
Yeah.
Do you understand how that's worked?
Yeah.
Good. So more often than not in vectors questions you'll need to be able to move between points. So I've got a line here and the line is A, B. Okay, I know you can see the A. There we go. Can you see the line A, B there?
Yeah.
Yeah? So going from A to B is represented with the 2 letters A, B with an arrow across the top. And the reverse, going from B to A, would be B to A in that direction with the arrow across like that. Is that okay?
Yeah.
Good. Most of the time, such a vector will be defined in letters in bold type. or with a line underneath them. So you will see a bold A between A and B, or an A with an underlining. Okay, thus we can say that AB going from A to B is equal to a bold A. Okay, or if we're going the opposite way, the sign of the vector would be reversed. So going from B to A with an arrow on top would be negative bold A. Okay, is that alright?
Yeah.
Good. Parallel vectors are equal. So notice here I've got two lines, AB and CD. Yeah?
Yeah.
Both of them are defined with a bold arrow A. Can you see that?
Yeah.
So A to B with an arrow above it is going to be equal to C to D with an arrow above it, and that will all equal A. Okay?
Okay.
Or going the opposite way, B to A and D to C, you're going to get negative A. Are we happy so far?
Yeah.
Good. These vectors are also parallel. So can you see I've got A to B there and E to F. Okay? However, E to F is half as long as A to B. Okay? So if E to F is a half of AB, then it makes sense that it's going to be a half A.
Yeah.
Or you could say that double EF will give you AB. That's another way of saying it. Is that alright?
Yeah.
So the important thing to note here is that they are both the same vector, but are multiplied by a scalar multiple, here of a half. Okay?
Yeah.
This idea of same vector, different scalar is used frequently in exam questions to prove that points are on the same line. So it's a really important thing that you understand that. Yeah? Good.
Yeah.
Let's have a look at resultant vectors some more. So it's very common in vectors questions for you to have to travel from one point to another via one or more intermediary points. And you must spell out the route you're going to take. So you'll see here on the left I've got a parallelogram, ABCD. Yeah?
Yeah.
It's got A to B defined as 3A. Yeah? And B to C defined as 4A plus 6B. Okay?
Okay.
Find the distance AD. So if I wanted to go from A to D, what you're doing is, if I show you this, you're going along this line here. That's the question. That's what we want. Okay?
Yeah.
However, there is no direct route to go from A to D. We have got to go all the way around to get the same answer. Is that okay?
Yeah.
So, as I spell out here, AD is equal to AB plus BC plus CD. So we know what A to B is. A to B is just going to be 3A, this 3A here. Yeah?
Yeah.
B to C is 4A plus 6B. That's that there. Yes?
Yeah.
And lastly, C to D. Well, C to D is going to be parallel to AB,
Yeah.
but we're going the opposite way along it. We're looking for this vector here. Yeah?
Yeah.
And that's going to be negative 3A. It's negative because you're going in the opposite direction. Okay? But it's still the same vector. Okay? So if we do the math now and collect all the a's together, 3a plus 4a makes 7a. Subtract 3a makes 4a. Yes? And then add 6b. So I know that AD is equal to 4a plus 6b. Okay. The other thing you may have noticed is that vector AD is parallel to BC. Yeah, parallel sides of a parallelogram.
Oh, yeah.
So I could have just written the answer 4a plus 6b straight away. But it's important to know that you can go all the way round the shape if you don't know how to get there directly, A to D. Is that alright?
Yeah.
Good. Here's a question, okay? And we're going to go through this together, but I would encourage you to talk me through it. Alright? So, I'll let you have a look at the parallelogram. It is ABCD again, but there's a cross M that's in between AB, and there's a cross N that's in between BC. Okay?
Okay.
They tell us that AB is A. So if I draw a line in here, this vector AB that is going to be bold A. Okay?
Okay.
And then BC, this vector here, that will equal 2 bold B. So can you see that 2B okay there?
Yeah.
I could delete this line. Group and group. If I was to delete that line, that makes life a little bit easier. There we go. Okay, so M is the midpoint of AB and N is the midpoint of BC. Okay, so N is halfway along BC and M is halfway along AB. Alright, so here are some questions. We want to go from A to C is the first one. Okay, let me try and move this over so I've got a bit more space to operate with. There we go. So if I wanted to go from A to C, how would I do it? Well, the most direct route is to go across like that. Yeah, but we can't go that route because there's no line there. So instead, we're going to have to go from A to B. And then from B to C. Is that okay?
Yeah.
So we're told that A to B is bold A, which I'm going to write as A with a little line underline. And then I'm going to add B to C, which is 2B. Okay?
Okay.
So when I'm handwriting, I can't write A bold, but I can write A with a little underline and B with a little underline. That little underline is meant to represent bold type. Okay?
Okay.
Okay, the next question, if I just remove some of this working on the picture, says B to D. So if I wanted to go from B to D, my most direct route would be there, wouldn't it?
Yeah.
Yeah? But I can't go B to D. What other route can I take? B to
A.
B to A. Yeah, that works. B to A. And then
A to D.
A to D. Okay. So I'm going to put this in. What vector is B to A?
B. Oh, wait, what was it? Vector B to A.
Yeah.
Um.
We know that going from A to B is bold A. So if I'm going the opposite way, B to A, what would that be?
B.
Maybe if I go back a few slides, you'll see it. Parallel vectors was not it. Yeah. Does this help?
B.
Ah, this is the one. So A to B
okay.
is A.
Yeah.
B to A is...
Minus A.
Right. Let's go back to the question. B to A would be negative A then, wouldn't it?
Yeah.
Yeah? Can you see why? You're going against the flow of that A vector, A to B. Is that okay?
Okay. Yeah.
And then we need to do A to D. Can you tell me what A to D would be?
Would it be A?
So let me spell it out. It's this line here. Here's a hint.
Two B.
Yes, it's 2B. Why is it 2B?
Is it parallel?
Good. Parallel vectors are equal. Okay. Let's clean this up so that I can look at the next question with you. C is A to N. So if I want to go from A to N, I'm going along this line here. Okay? Yeah?
Yeah.
We can't go directly A to N, can we?
No.
What's the correct route?
We have to go from A to A. No, A to B.
Yes. And then?
B to A.
Good. A to B. Plus B to N. Okay. Looking at the picture, what's A to B?
To B.
What's A to B? I'm going from...
I think so. A.
It's A. Okay. And then what about BN? I'll scroll up so you can see it again.
Minus A.
No. So let me just show you. We have done this part here. That's
Oh,
our A. Yeah?
Yeah.
We've now got to do this part here. So what's that vector going to be there? B to N. That should help.
Oh. B.
Yes. It is just going to be B. Can you tell me why?
It's half of 2B.
Good. So the answer here is just A plus B. Okay. Let me erase this mess so that we can look now at part D. Okay, so MC is what it wants next. So I have to go from M to C, which is this line here. Is that alright?
Yeah.
Okay. Now I can't go directly from M to C, but I can do this. Yes?
Yeah.
So what are those distances? I'm going first from M to B. And then from B to C.
Yeah.
Let's extend my page. So what is MB, this first part?
A.
Nope.
Wait. M to B.
Yeah, this bit here. What value is that going to have?
Minus.
No, you're still going in the same direction, A to B. But M is the midpoint of AB. So what's this distance going to be? The clues there highlighted in green.
Would it be half of A?
It's a half A. Good. 1/2 A. Okay, so I'm going to put that down here. Equals 1/2 A plus B to C. Well, we should know that that is
2B.
2B. Good. Is this making sense how this is working, yeah?
Yeah.
Good. So I'm going to clear the workings that I've done from the previous question, and let's have a look now at the last 4. So that I was not wanting to do. That helps, gives me a little bit room. Okay, so the next one is C to M. Let's look at the picture. How do I get from C to M? Well, the fastest route is like that. Yeah?
Yeah.
But I can't do that. I'm going to have to go from C to B. Yeah?
Yeah.
So I'm going to write that down. C to B. And then I'm going to have to go from B to M. What's C to B?
minus 2b.
Minus 2b. And what's bm?
Pardon?
What's bm?
Minus a half a.
Good. I think you're starting to get this now. Yeah?
Yeah.
Minus 2b minus 1/2 of a. Okay, next is NA. So if I get my pen and wipe this again, I need to go from N to A. So the most direct route to get from N to A is this route here. Yeah?
Yeah.
I'm going to have to go N to B.
Yeah. And then b to a.
Good. What's N to B?
Minus b.
Minus
Wait.
B.
Yeah,
Yep.
minus b.
And then B to A.
Minus a.
Excellent. I think you're getting this now, which is good. Okay, next question is M to D. So hang on, let me just shrink this a little bit so that there's room for me to write here. Okay, so we want M to D. Okay, the most direct route from M to D is this route here. Yeah? How do we do it instead?
Go from M to A, which would be minus a half a.
Yep, minus a half A. Yep, and then A to D.
A to B, which would be minus 2b. Wait, 2b.
It's just 2B.
Yeah.
Okay, I should put these. Yeah, okay. So let's spell that out. Equals M to A plus A to D. So it was minus a half A plus 2B. Good. And lastly is the most difficult one. I'll clean up the board. So I need to get from M to N. Okay, let's look at the picture. How do I get from M to N?
You go from M to B first. So
Yeah.
that would be a half a.
Yes.
And then B to N, which would be just B.
Good. So notice I'm going to write the correct notation down. So it's going to be M to B plus B to N. Yeah? It's always good to spell out what you're doing. M to B is a half A. Is that okay?
Yeah.
And B to N would be B. Okay. Are you happy with how that's worked?
Yeah.
Good. So on the next slide, I've got the actual answers. Okay. Spelt out without any mistakes or workings, but I'll give you those in a moment. How much time have we got? We've got about 5 minutes, so I'm going to try and get through another question. Okay. Here's a question that I've pinched off an exam. So we've got a hexagon here, A, B, C, D, E, F. Okay.
Yeah.
And can you see that the vectors are defined as O to A being A, and O to B being B. Yeah?
Yeah.
It wants us to get from A to B as the first question. So I'll try and scroll down. Write the vector AB in terms of A and B. So if I use my red pen, okay, where's my red pen? I need to get from A to B. That's this line here. Yeah?
Yeah.
So the route I'm going to take is this route here. Yeah?
Yeah.
A to B equals A to O plus O to B. Yeah. Can you see that A to O is going against the A that they've given? So it's got to be negative A. Yes?
Yeah.
And then I've got to add B because O to B is B. Is that alright?
Yeah.
So I've written that here. A to B equals A to O plus O to B equals minus A plus B. We happy with that so far?
Yeah.
Right, I'm going to rub out my workings. Let's look at the next part. The next part says that the line AB is extended to the point K, so that AB to BK is 1 to 2. Okay, so I've already done this at the top. I've extended the line AB to point K. Okay,
Yeah.
and they tell us it's in the ratio 1 to 2. So 1 to 2 as a ratio means 1 plus 2 to get 3. And then you're looking at 1/3 to 2/3 as the ratio. Yeah? So
Yeah.
that picture at the top now should make sense. That AB is going to be 1/3 and BK will be 2/3. Does the picture make sense?
Yeah.
Good. Write the vector C to K in terms of A and B. Give your answer in its simplest form. So the total distance AK can be divided as shown using the fractions calculated, and that's what we've just done. Okay. So we want the vector CK. C to K, I will draw on with a red pen, is this vector here. Is that alright?
Yeah.
Okay. So the total distance A to K can be divided as shown. So 1/3 of the distance AB, yeah, that's that distance, equals minus A plus B. So B to K must be double that, 2A plus 2B.
Yeah.
So C to K must be CB plus BK. And I'll just go back up here to show you. C to K, well, the route we're going to take is C to B, that line there, yeah? And then B to K, that line there. Okay? Can you spot the relationship between CB and OA? Why is that statement true? CB equals OA. You've been through it.
Parallel.
Vector vectors are equal. Is that all right?
Yeah.
So I know that this distance is A. I've just done it up the top. Yeah, CB equals OA equals A. Then B to K is double the distance AB, which is minus 2A plus 2B. And if we add those two together, we will get minus A plus 2B. As A take away 2A will give you negative 1A, and the 2B will just be on its own. Okay? And that's the answer to the question, vector CK in terms of AB. Is that okay, or did that not make sense to you at all?
It was alright.
It was alright, okay. I think the key to this is to notice that 1/3 is a half of 2/3. So if I times this distance by 2, I'm going to get that. Yeah?
Yeah.
And I know that AB is this, because I've just worked it out in the first part. Yeah?
Yeah.
So if I double that, I'm going to get negative 2A plus 2B. And that equals the missing distance BK. If you can spot that, the rest of this becomes quite simple. Yeah.
Yeah.
Good, so we've run out of time here. Hi everyone, this is a friendly reminder to like, subscribe and hit the bell notification icon to stay tuned for future videos on this channel. I also welcome constructive comments in the box below, and you can gain access to any of my teaching resources through the link above. If you'd like to support me through donation, you can either go to paypal.me/JonathanKipping or patreon.com/JonathanKipping. Stay tuned and look forward to future videos.